Today we are resuming lesson 6.6, and we'll be using transformation to sketch a graph of a trig function. So there are two parts, and the second part we'll be looking at writing equations of the graph of a trig function. Just to recap, the transformation, the general transformation of an image of y equal f of x is y is equal to af of bx minus c plus d. Or if you can write it y going to be equal to a sine b into x minus c plus d, or cos. So that's your, and for this year we can be able to find the values for a, b, and c. Just remember a is your amplitude or the vertical stretch. And the amplitude, we can find that by the maximum value minus the minimum value divided by 2. So this is your stretch or compression. So if a is greater than 1, we have a stretch. And if it's between 0 and 1, we have a compression. If it's negative, we have a reflection about the x-axis. The b is a horizontal stretch or compression. In other words, it will reduce or increase the length of the period. So remember, we have that b is 2 pi over the period. So whatever the period is we take 2 pi divided by the period, and that will give you the value for b. So if b is a fraction, or between 0 and 1, we have a stretch. If it's a whole number greater than 1, we have a compression. And it's by a factor of 1 over absolute value of b. The c is a horizontal translation. So if it's negative, it's to the right, and if it's positive, to the left. And d is a vertical translation, or what we also call the midline. So c is a phase shift and vertical translation, and now d can be found by the maximum value plus the minimum value divided by 2, which is a midline also. So that's a general overview of the graph. So we'll be using it. The first example question we'll be looking at using transformation to sketch a graph of a trig function. Here is a general form, y equal to, and then we have our a here. A is 1. In this case, a is 1. So we have, so sketch a graph of the function y equal to sine x minus 30 degrees plus 3. So first of all, if you look at this here, we translate it into this form here. This is your d, which is your vertical translated. So it's translated 3 units to the up. So d is equal to 3, which is equivalent to translated 3 units up. Now this is what we call a vertical displacement. It's moving up. Then our amplitude is still 1, right? Because we haven't changed. That hasn't changed for the a value. But what has changed here, the transformation occurred, is that the phase shift, a horizontal shift. So c, horizontal shift, is 30 degrees to the right. Now, let's go ahead and look at. So first of all, if you look at the regular sine function, and here I've labeled out in degrees, show it better here. So if you have a regular sine function, it will have 360 degrees. Now, generally speaking, we would like to have the what we would refer to as the mean points, right? Or the key points. Now, this is a cycle when we know a sine with 360 degrees is here. So now we halfway is 180. So these are our main points, our beginning and our end. So we have key points, right? So we have our key points. So we have beginning, the ending, and we need a middle. And then we have between the two, the middle and the beginning, and the middle and the end. So we have 5 points altogether. Okay. So here's our cycle. We have 180 degrees. We have 90 here of 4 points. So here would be my sine function. 8 points here, 180, 270, and 360. This would be our sine x function. So this is y equals sine of x. But our equation is y is equal to sine x minus 30 degrees plus 3. So now it shifts now 30 degrees to the right. So everything shifts now 30 degrees. Now each one of these increments is 30 degrees. So now we will be up here. If I use a different, maybe a highlighter. So here's my points. Now we shift 30 degrees to the left. So now this is this graph now is y is equal to sine x minus 30. Now I didn't translate it up or down. But now they tell us it is vertical shift positive 3. So this has to go up 3 units now, right? So now I move up 3 units, 1 unit here. So you have 1, 2, 3. Now, by the way, I just indicated here my midline. My midline is my D, which is 3. So that's your new your midline here is 0. Y equals 0 is a midline. But now, it's initially, if I have this, the midline here was 0. So this graph is y is equal to sine x minus 30 plus 0. Now the 0 is a midline, but now this other one now is 3. So you can see it'll make sense. You go up 1, 2, and 3. So you start from here, so a new graph. So go up 1, 2, 3. 1, 2, 3. And we have over 1, 2, 3. And then we have 1, 2, and 3. So this is my so the graph y is equal to sine x minus 30 degrees plus 3. This is my new midline. Notice what I put here, this is my minimum, and this is my maximum value. So it tells me my amplitude is 1. So my phase shift is 30 degrees. That's what it is here. So this graph shifts 30 degrees to the right. So that's my new y to sine x minus 30 degrees plus 3. So everything shifted. 30 degrees. Now, you can go about without doing all of these sketches here by going directly here. And to do that, you would like to, first of all, find your midline. Midline is your y value here. Your d value. Once you have your midline, you look at your amplitude. And you know your amplitude would be 1. So it cannot be higher than 1 because it tells you your amplitude is 1. So it will go from 3 to 4, and the minimum will be 2. So once you have that, you know that a sine function is 360 degrees, but because there's no b value, the b value is 1. There's no horizontal compression, so it maintains the sine function. So we construct the sine function, but it's 30, so this will be 60 degrees here. And we know this will be 360, and it's shifted to 420 degrees. Oh, sorry, this would be 420. This would be 390 degrees. Oops. So it ends at 390 degrees. This is it's shifted by 30 degrees here, not 60. That's what it says here. I'm thinking of the next question. Shifted to 60 degrees. So that's how you go about doing a sketch. So step 1, find the d value, or find each value. Find the a value, find the b value. In this case, b is equal to 1, which is 1 over absolute value of b, which is 1 over 1. So there's no horizontal compression. So A, B, C. So once we have those, then we can go ahead, find our midline, find our amplitude, and then find our shift and compression. So here we have a little bit, once has everything in it. Sketch a graph of the function y is equal to 3 sine bracket 2x minus 2 pi with 3 plus 2. The first thing you want to do in this case here, you want to change this, rewrite this function in standard form. So step 1, rewrite the function in standard form. The function y is equal to 3 sine 2x minus 2 pi over 3 plus 2 in standard form. Y is equal to a sine b into x minus c plus d. So what it changes for me, because we need to factor out the 2. Right? So here we have y is equal to 3 sine 2x minus 2 pi with 3 plus 2. We factor out the 2 to give us y is equal to 3 sine. Now factor out the 2 becomes 2 into x minus pi over 3 plus 2. Now we can have that's our d, that's our c, that's our b, and that's our a. Okay, so we can start to put some information down here. We can know that our amplitude is 3. In other words, our vertical stretch, Then we have, which is A. The B is our horizontal compression, right? So horizontal which is 1 over absolute value of B, equals 1 over 2. So now this graph is now compressed by a factor of 2. So compressed by a factor of a half. In other words, the period now, remember period is equal to 2 pi over the B. So a regular sine graph has a period of 2 pi, but in this case, or 360 degrees. Since we're working in radian, we'd stick with the radian. So the period now is 2 pi over 2, which is equal to pi. So now this function has a period of pi. Now a regular sine function has 2 pi as a cycle. But now we're looking at 1 pi. Now, I just want to look into this here. If you look at your, remember, any kind of a cycle, we'll be looking at transformation. So here is my, and we're going to use the cos in a minute. So horizontal stretch. Now, if it were degrees, we have 360 degrees. Okay. So now we have horizontal compression, and that was half, or it's easier to look at that is the period. Period now is pi rather than 2 pi. The C is your horizontal stretch, phase shift, or horizontal translation I mentioned. So horizontal translation. And this has a horizontal translation of pi over 3, and that moves to the right. So pi over 3 units right. And the last thing we have here, our vertical translation 2 units up, or the midline equals 2. So we're going to use a set of information now to do our sketch. So we have the period. Right. Okay. So now we'll have here's the graph. So we're going to use so we have a horizontal stretch. Now, first thing we could do is to sketch the graph of y equals sine x. So what I'll do in this case here, so now since our shift, I'm going to move this up a little bit here so we can see. I'm going to go to my, I'll just write my equation back here. Y is equal to 3 sine. Can you highlight it? Three sine 2 x minus pi over 3 plus 2. Okay. So we know the period. Okay. So the period now is equal to pi, and the amplitude is 3, the midline is 2, and our phase shift is C is our phase shift, which is equal to, this is our B here. Phase shift is pi over 3. So we'll go ahead, step 1 will be 0 here. We'll go ahead and we'll do a sketch of your sine function. Okay, so we'll have, here we have pi so we have pi over 2 here. We have pi 3 over 2 pi and 2 pi. Here we have 1 and negative 1. So our sine function is going to be regular sine function. Okay, so we'll increase these, we'll need them. Okay, now we have a period of, sorry, of pi. We have an amplitude of 3, right? So we can apply first, so we do the first sketch. The next thing we want to do, we want to do a graph that shows you where the amplitude is 3, but the period is 1. Right? So we'll, and our phase shift is 2. Let's do all in one. So we're going to put this up to 2 now. So let's do a new graph here. So now we have pi is now our new period. So we'll, now this becomes 2. So these are our key points, right? We have a beginning or end, the middle, and the quarter and 3/4. So beginning, quarter, middle, a half, 3/4, and a whole. So this is going to be pi over 2. So this is our midline, which is d is equal to 2 or y is equal to 2. That's my equation. Now my amplitude is 3. So I'll go up. So my 1, 2, 3. Then I go down 1, 2, 3. So this graph will go, oops, down here. So this is my minimum here. So 1, 2, 3. So this will be my range, my minimum. This is my minimum. This would be my maximum. So since it's a sine function, it's 1, 2, and there you go. Oh, no, I'm here. Here. So now I'll do this graph here. So now we've completed our amplitude. We're looking at our phase shift or horizontal compression. Oops, here. So this is my horizontal compression. So I have that all done. And now here is our horizontal. We need to have a horizontal translation of pi over 3. So now here we have, this is pi over 2. So now instead of beginning at this point here, it now begins at pi over 3. Okay, so this is my new beginning. And it ends at pi plus pi over 3. Okay, so what I mean by that, I'll just show you in a sketch here. Maybe I should use a different graph, but so here's my midline at 2. Here's 0. So now it's, if we have pi, it ends at pi plus pi over 3, which gives you 4 pi, because it's 1 pi, 4 pi over 3. And it begins here at pi over 3 and ends at 4 pi over 3. So now that's what I meant by that. So now this point here ends at 4 pi over 3. Because it's pi, put it up here. So this point, 4 pi over 3, is really pi plus pi over 3, or 1/3 pi. So 1 pi plus 1/3 pi is 1 1/3 pi, which is the same as 4 over 3 pi. So it starts here now at pi over 3. So now we need to find our key points. So our key points now, so now our new interval, so the interval, let's put my notes here. So go back here, the interval where, in this case, where x is between 4 pi over 3 and pi over 3. So now we want to find out, locate our 5 key values. So our beginning here, our first one is pi over 3, so our last one here. We need to find the ones in between. Okay. So now we need to find the values in between. So the middle here, the middle value would be equal to, you add this 2 and divide by 2. So the middle value, right, would be pi over 3, the beginning here, plus 4 pi over 3, and divided by 2. So that gives me what, 5 pi over 3. Now divide by, multiply by a half, will give you 5 pi over 6. So to write down the middle here would be 5 pi over 6. So we have, so our point's going to be, so we have 5 pi over 6, so our points be here. So our beginning point, pi over 3, or end point, 4 pi over 3, or middle point is 5 pi over 6. Now the two other points here are going to be 7 pi over, then we find the middle point between these two, 7 pi over 12, and this will be 13 pi over 12. To find these two, you simply find the middle between these two. Simply add them, divided by 2. So 7 pi okay. So this is basically pi over 3 plus 5 pi over 6 divided by 2. And that will give us, that will give us 7 pi over 12. So now go back to my graph. So the first one here is 7 pi over 12. So here is our middle. This is 5 pi over 6. And right here, it will be 13 pi over 12. So 13 pi over 12. Okay, so I'm going to write it down here. So the first one here, pi over 3. Middle here, it will be 5 pi over 6. Then 13 pi. This one in the middle here. Oh, so it should be here. So here's our point. Start from here, goes up. Your pi 3 will be here, so graph will go up, down here, go here, and back up. So this is our new sketch. So here's our midline. So now a shift now, instead of being from here, it's now pi over 3 to 4 pi over 3. So recap, if you're given an equation of this form, you have to make sure you rewrite the equation in standard form. Then find your amplitude, your horizontal compression or stretch, or basically find the period. Then find the horizontal translation and the vertical translation. You can start out by looking at a sketch of a standard sine X graph, and then begin to make a transformation, which is the amplitude is 3, meaning a vertical stretch. And in this case, we have the period worked it out as 2 pi over b, which works out to be pi. And the d, which is our vertical translation, become your midline. So you start out by constructing your midline here. Then you would construct a sine function with the amplitude and a new period, and then you do the shift. In this case, shift to the right. When you're doing a shift, you find your beginning point, and the end point would be the beginning plus the length of the period. So my beginning point is pi over 3. The period is pi, so I add pi to pi over 3 as the ending. So beginning and ending. To find the middle point, you add the beginning and the end. The sum of these two divided by 2 give you a middle point. The point between the beginning and the middle, it's your beginning plus your middle values divided by 2. And the point between your middle and the end is your middle plus your end point divided by 2. Now, these are a little bit complicated in the sense that they're dealing with pi. And it's a little bit trickier because you have to do a lot of fractions. If they were in degrees, it's much more straightforward. And you probably want to try some of the questions in your assignment booklet. Okay, that's a question there. Now, in your assignment booklet, you may want to try out some of the questions on page 532, you want to try question 1, and on page 535.